Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Faisal Muhamad. Today I would like to present about my final year project, which is tribological properties of a recycled vegetable oil based lubricants for MQL cutting condition. Before I start my presentation, I would like to give special honorable for my supervisor, which is Dr. Nur Hayati bin Abdul Halim, who is guide me along this semester. Okay, let's start my presentation.
Project summary. The requirement of lubricating oil is growing every day, yet current mineral oil-based lubricants are not biodegradable, directly harm soil, deplete quickly, and would run out in a few decades. To solve the problem, treatment of recycled vegetable oil for use as a lubricant in a high-speed milling machine will be the main topic of this study. Viscosity, surface roughness, friction force, coefficient of frictions, temperature, and two will be determined. According to the result, treatment recycled vegetable oil may be utilized as a lubricant during the machining process and to build a sustainable environment for the future. Introduction. Conventional cutting fluid perform cooling and lubrication tasks, but when used as lubricant during machining, they cause several technological and environmental issues. Even while standard cutting fluids are often utilized by companies in a variety of applications, they can have drawbacks such as word cancer, respiratory illnesses, and skin irritation. According to the Abdul Salam's researchers, about 38 million metric tons of lubricant were used worldwide in a form of cutting fluid by industry enterprise. With an expected increase of 1.2% per 10 years. Like a vegetable oil, the use of vegetable oil is organic, fast biodegradable, almost non-toxic, and environmentally safe. It offers a steady supply of raw materials for creating of environmentally friendly goods. As a result, the minimum quantity lubricant approach will be used following by the application of treatment recycled vegetable oil in a high-speed milling machine to reduce lubricant waste. Problem statement. There are three problem statements. First, not many of researchers offer a deeper comprehension of oil's characteristics and performance, especially in treatment recycled vegetable oil. Second, it is critical to handle treatment recycled vegetable oil appropriately. That the capability of different lubricants has several effects on the tool's ability to survive operation in high-speed milling of mill steel under MQL. Objective. First, to conduct a treatment on recycled vegetable oil and assess its fluid viscosity characteristics. Second, using treated recycled vegetable oil with a tribometer on an uncoated carbide pin and a mill steel disc to discover weight and friction behaviors in terms of friction force, coefficient of friction, to weight, and temperature. Third, to evaluate the treated recycled oil's effectiveness as a lubricant. Scope and limitation. The experiment will use cooking oil with a palm oil base and will done in the Uitm Shah Tribology Lab. The purpose of this experiment are to find the effect of hardness, surface roughness, and weight and friction behaviors such as friction force, coefficient of friction, tool weight, and temperature produced at the pin on disc. Limitation. There are two limitations. First, the experiment only focused on high-speed milling machine to test lubricants. That's because no data comparison is done with the other machines such as grinding machine, drill machine, and so on. The data comparison can be done by taking the experimental data collected by the previous research. Second, the success of the project depends on the item and the equipment available in the Uitm laboratory. Literature review. There are four main topics focused in the literature review. First, sustainable machining. Second, high-speed milling machine. Third, MQN and lubricant. And last but not least, treatment recycled vegetable oil. Sustainable machining. Sustainable machining is a method for the manufacturing that minimizes waste and reduce the environmental impacts. In other words, manufacturing is the one of the industries most strongly target for the applying of the sustainability principle due to the hard use of natural resources and adverse impacts on the environment. The machining has been promoted as a technology that produces less waste, use less energy, and improve safety procedure. It is also be more safe, cleaner, and more economically friendly. Some of the sustainability factors are the use of the coolant and lubrication, service life, velocity, and energy use. Thus, optimize the input and output of the machining processes through analysis has major implication of the sustainable manufacturing. High-speed milling machine under MQL. In contrast to the conventional methods, high-speed machining generate a greater rate of the metal removal, low cutting force, and no critical heat of the workpiece. However, the high cutting temperature produced by high-speed machining lead to the cutting tool quick rate of the tool weight. Consequently, cutting fluid is required as a lubricant to lower the temperature and increase the tool life. MQL and lubrication. Minimum quantity lubrication is a clean manufacturing technique which is also known as a near-dry machine. Minimum quantity lubrication is beginning to displace fluid lubrication due to the advantage in terms of the environment and fluid cooling. MQL-based machining involves using a tiny quantity of cutting fluid to accomplish both lubrication and cooling between the substrate and the cutting tools. In other words, MQL drastically reduce amount of cutting fluid by spraying in the cutting zone. There are several types of MQL lubricant available for using during machining, such as the synthetic oil, vegetable oil, and palm oil. Synthetic oil, vegetable oil, and palm oil are more commonly used as a lubricant in the industry. Trimmer recycled vegetable oil. Trimmer recycled vegetable oil focus on recycling old oil for use as lubricant. An example old oil here is cooking oil. Cooking oil are produced in a vast amounts all over the world. By doing treatment, it may decrease oil waste, particularly hazardous to the environment. Cooking oil will improve sustainability. Three critical methods to make treatment oil are: first, filtering with certain materials; second, solubility-based separation; and third, boiling point-based separation. Methodology. First, prepare a mixed disc and uncoated cardboard package. There are three processes involved. First, cutting process. Cutting process is used water jet. It also to remove unwanted particles. Second, grinding process. The process is to remove bark, obvious mark, and rashness on surface specimen. Third, polish process. Polish process is to make specimen surface clean like a mirror. Second, provide a treatment for use vegetable oil. At the percent ratio of plant kernel activate carbon to absorb extra fats, utilize the chemical, and get rid of the bad smell for every 50 grams of cleaners used vegetable oil. Heat the mixture on the HS2 magnetic stirred hot plate for 80 minutes at 100 Celsius to remove any remaining water. Third, characterization on the treated recycled vegetable oil. Evaluate the viscosity of the oil both before and after treatment. To get an average, 3 readings for each oil were collected. 4. Analyze a tribological system. Pin on this testing was used for the tribological testing, with might still used for the disc, and the tungsten carbide used as a pin. The primary objective of the research is to identify the correlation between waste processes and variables, include the contact pressure, slide velocity, and the specimen's surrounding. Last but not least, analyze the hardness and weight behavior in terms of the friction force, coefficient of friction, to weight, and temperature. The weakest hardness test machine is used to gauge the specimen's hardness. For location on the specimen was subjected to a load of 1000 Newton both before and after the tribological study was completed. The pin on this test revealed the weight behavior in terms of friction force, coefficient of friction, the weight, and temperature. Expected result. There are three expected results. First, able to prepare treatment, recycle vegetable oil, operate a high-speed milling machine efficiently, and set up the necessary settings that are required. Second, the proper parameter for measuring surface roughness, friction force, coefficient of friction, temperature, and to weight on an uncoated carbide pin and mill steel disc in a tribometer machine are efficiently acquired. Third, able to produce a perfect sample of an uncoated carbide pin and might steel disc to be tested at a pin on this experiment will not or minimal defects. That's all for me. If you have any question, you can contact me at number phone here, or you can email me at the personal email or student email here. That's all. Thank you. Assalamualaikum.